Good. What's the matter?
Oh, nothing.
Start again.
Good morning, ladies and gentlemen. How are we doing today? Wonderful, great, excellent. Glad to hear. Love these conversations that we have early in the morning, ladies and gentlemen. Love them, love them, love them. So, all right, let me get attendance, ladies and gentlemen, and then we got a lot to do.
That's so weird. That is so bizarre.
Josh.
You like the first Stop that. That's so
Josh. Nope, the other one. Josh. Hernandez. Nope, he's the one we're missing. All right, wonderful. Excellent. Incredible. Good. Six.
just discourage the side. Your little name. Oh, that's straight. Open your eyes. Did you guys have Robson last night?
All right, ladies and gentlemen. Today, you need to finish getting your observations in the mass of your samples. So I took them all out. I put them on the counter back there, ladies and gentlemen. Find the one that is yours. Take and make your final observations of the dry residue that is left afterwards, your precipitate that was formed. Go up to a balance, ladies and gentlemen. Find the mass on the balance.
Makes sense.
Yep, you're cool enough. Go. Then I am going to need your mass of precipitate for your group. Whether it was 10, 5, 15, whatever. So going back, make your observations, get your mass of everything. Please remember to then subtract the mass of the empty beaker with your name on it and the mass of the filter paper to get just the mass of the precipitate in there. When you are done, ladies and gentlemen, the filter papers go in the garbage can and the beakers come onto the table or the cart in the back here. So that is where I want your beakers.
What?
Is that it? Can you put it in form? Or is that not?
Right.
We'd say that it's form.
I want you to make observations of the sample, not of the heat. Why? Because it came out of a drying oven.
Again. Is it still that way? It's still
Look closely at the top. Take the filter paper out. Make some observations. You can touch it. I don't care. It's dry now. You can touch it. Do not lick your finger after you touch it. It is lead, ladies and gentlemen. Lead is a poisonous heavy metal.
Oh, so let's happy.
From a poisonous heavy metal? I don't know. Maybe that's why they call it poisonous.
Should we do the math with this?
You put the whole thing on the balance. You get the whole mass. Then you subtract the mass of your empty beaker with your name on it and your filter paper or papers. But all you're going to do is take this mass.
I mean, there wasn't a snow.
Minus those
I
two
can't put my
numbers.
hand in there. I didn't smell it.
Because you had two papers. She's got a calculator, Phoebe. She waited until you were all the way over there though to tell you.
I literally was like, Phoebe, give mine. I just walked away. I swear.
Yeah, dude.
And you subtracted the mass of the filter paper as well? Again, the paper can go in the garbage can, and then the beaker on the cart here. Nope, I will take care of it.
When you try it, you need it.
I know.
I'm going to, but get it all done, get back to your seats, and then I will get it from you.
Honey?
I was about to alright. Yeah, the texture of salt.
No! When you are done, you put the beaker on my cart here. You throw away your filter paper, but do not flush this stuff down the sink. Again, lead is a poisonous heavy metal. Probably not the greatest idea to put it in the drinking water for the city of Green Bay.
Do we wash our hands?
Yes, always wash your hands when you leave the class. But no, transparent means that you can see through it. Translucent means light will pass through it, but you cannot see through it.
I have a bowling pass for so long.
Oh, you gotta get
Hold on, I understand.
Yeah, I haven't used the system there.
I've been able to.
I just don't know.
I
What are the
understand.
X's on?
You gotta actually
I don't
look at
know.
the video. It like tells you what you do. It
It's
tells you
creepy.
what you have to do.
Even the
This one
E3
uses forever?
exclusion was 0.500 molarity. Calculate the number of each reactor used. I should look see here.
You look, see.
I will look see here.
So you're trying to be sneaky.
Kid, why do you think I don't go walking? Rank 3.
Okay, so
Oh wait, I have feelings. But I thought.
I haven't seen you. Maybe you were looking for less than.
Yeah.
Well, what's that?
actually, this is
Okay, yeah. So it's supposed to be
Really good?
1.7.
Okay, good, good.
Okay, here's the other thing. I wrote 2 down, so there's 2.3.
Can I get a one? Please.
But then we got 10 million.
Oh.
So I don't know. So I guess we'll find out. But that number's pretty close.
so you probably is the end
Yeah.
of being
That thing
Oh,
is good.
Steven?
Yeah.
On Instagram, I thought it was Steven.
What'd you guys get?
I didn't look at anything for the
ours
reaction.
That's you.
I mean, you guys want to.
This one though,
That's his name, dog.
it should be. Here, this one was 11. It's not.
So then what are we?
Yeah, my yawn.
I don't know.
What was it?
I guess we'll find out.
Where?
11.
Ladder.
I keep forgetting the word
You
child.
can eat it,
I
it's
only
not
have
that
like
bad.
my.
Are you being serious or lying?
Yeah.
I'm joking.
The actual.
Say what, pendejo?
Wait,
You're being-
Next time you need it.
Alright.
So I got like a 2 pack.
Gracias, no,
There you go.
Toss um bolinho. Toss um bolinho.
Troca o nosso?
Yeah.
No toqué nada, tú.
Does the lip gloss taste good? No, because it hurts my. Oh yeah.
Yo,
Like makes fun because my
Just
so I use the college and stuff. Yeah.
Very sophisticated.
Oye, no, you're nasty. Very good.
All right, ladies and gentlemen, here we go. I need your masses. I need the mass that you found in the experiment. So, 5 milliliter groups. We had 2 of them. Someone give me the mass for your trial, for your group. Please, don't everybody shout out all at once. Tell me what the mass you got for your sample for 5 milliliters. And
0.93.
okay, 10 milliliters.
I got 1.62.
1 point what?
62.
Okay, the other 10 milliliter.
1.473.
The 15 and
2.019.
the 20
2.078.
and the other 20.
Oh, well, we did it wrong, but.
That's not what I asked.
No, 14.477.
14?
Yeah, I know.
14.
Yeah. We did it wrong.
0.477?
Yeah.
How the hell did you get 14?
Yeah, I don't know.
$25, please.
1.893. 1.893.
And
2.48.
30 mils.
2.618.
And there was no other 30 mil. All right. Now you got to wait till tomorrow, or I'm sorry, till Monday, because I have to get the ones in for second hour before we can do anything with this, ladies and gentlemen. You subtracted the mass of the filter paper and the mass of the beaker? Okay. So today, ladies and gentlemen, you're going to do a little calculation here. The calculation that you're going to do, ladies and gentlemen, is called percent yield. Now, if you remember, in the gas law lab, we did percent error. And percent error was equal to your experimental value minus the accepted value over the accepted value. We wanted this to be a very low number, okay? 0 is the best percent error. Low numbers under 5% are very good. Percent yield is another way of seeing how well you did the lab, but it is the opposite way. In other words, we want a high percent yield. But the highest percent yield you should be able to get is what? 100. Eric, congratulations. You're going to be at 700. You are an ultimate overachiever. No, something went terribly wrong. And again, not really sure what happened, ladies and gentlemen, because you took 4 masses and you should have subtracted them. Again, I'm sorry, you took 3 masses.
I don't know how that happened.
Amazingly, overnight, your beaker lost a lot of mass somehow or something. No idea. Percent yield, ladies and gentlemen, is found by taking your experimental value, the value that you just gave me, divided by the accepted value. And then times 100. Now again, this number should be close to 100 without going over it. So write this formula down somewhere because I'm about to go back to your data so that I can show you what numbers to use. Bless you. Does anyone need more time to copy the formula down? I will accept utter and complete silence as no. So, these are your experimental values. These are the accepted values. So you take your number divided by this one times 100. Congratulations, this is almost a 300% yield. This, about 180%. Here, about 160, 130, somewhere around there. Here we're getting closer. Hey, this one is finally under 100%. This one is under 100, this one's over. This one's over by a bunch. So this is like 110%, this is like 105%. Do your calculation, ladies and gentlemen, and put your percent error into your lab. Let me show you where it goes. Oops, sorry, I'm looking at the wrong week. My bad.
What was the point after it?
Pero no nos ha enseñado. ¿Qué es eso?
So down here, ladies and gentlemen, where it says calculate the percent error, I want you to highlight which trial you had. Trial 1 was 5 milliliters. Trial 2 was 10. Trial 3 was 15. Trial 4 was 20. Trial 5 was 25. Trial 6 was 30 milliliters. So I want you to highlight the one that you had. Okay? So up here you can either change that box to be a different color, like this, or some way of highlighting which one was yours. Okay? Which one was yours? And then you should put your number in below it. Questions? percent error, the unit is percentage. That is the unit. Because your actual units of grams and grams cancel out when you divide them. So your unit becomes percentage. Okay? Yes? Oh, by the way, take it times 100. My bad. Times 100 because it is a percent. So your value that you got, the grams, minus the accepted value, I'll go back to those again in 1 second, times 100. Question? Was that the question about the 100? Okay. So again, ladies and gentlemen. Okay. These values right here are the ones that you are going to use as the accepted value because that's how much we should have gotten based on our calculation. How much we should have gotten. This is how much you got. Now, I will give you access to this, but I have to get all the data into it first.
Wait, trial 1 or trial 2?
Which one was yours?
15.
Okay, which number was yours?
2.3.
Then that's the one that you use compared to this. Now, I'm glad you asked that because I was just going to tell you, you have to do the percent error for your calculation, but you also have to do them for all the others. Now, for all of the others, you are going to use the class average compared to the what you should have gotten. Okay? The class average. But you will have one of these that you'll just use your own. And I want to see that highlighted in that document. I want to know which one you had. I want to know what your percent error was. Okay? And then again, you're going to take the class average. Well, for right now, the all class average is the same. I will be changing this. The all class average will change when I put in second hours or third hours. Your class average will not. Okay? And again, I will give you access to this. I cannot yet. Okay? I cannot yet give you access to it. Because if I do, then when I make my changes to it, those changes will not come through for all of you. Okay? Questions? Okay. So, we will show you what to do with that when we get that. Questions right now? Okay. Let's go back to your lab for a minute, ladies and gentlemen. Okay. Question or calculation number 1. Now, for doing your calculations, you need to type up the calculation in here, or you need to do your calculations on a sheet of paper, take a picture of them, and insert them into your lab. I don't care which one you do. If you do not want to try to type out and format how we do these, I'm absolutely fine with that. Do them on a sheet of paper, but you need to put them into your lab somehow, and you need to label them. Here's my calculation 1. Here's my calculation 2, and so on and so forth. Okay? So given that each reactant solution was 0.5 milliliters, calculate the number of moles of each reactant used in each trial. Okay? So you are going to calculate the number of moles used in each trial. Now, which is the same in every trial? Nope. These are reactants, not products. It says, given that each reactant was this, calculate the number of moles of each reactant used in each trial. Which one was the same for every one of you? Nope. We varied in the volumes of sodium iodide. What did we not vary in the volumes of? Lead nitrate. You all use 10 milliliters of lead nitrate. You all use 10 milliliters. That means the moles of that is going to be the same for every one of you. The moles of sodium iodide are different. Okay? But you need to do the calculation for each of the volumes, 5, 10, 15. Now, you do not have to show me all 6 calculations. Here you do the ones for your volumes, the 10 milliliters of lead nitrate and however many milliliters of sodium iodide you have. And you do not need to show me more than that, but you do need to calculate the moles of lead iodide that should have been produced in each trial. Okay? So, please remember 2 things. 1, you can only ever make the which amount? The smaller amount. And if you remember, for the first few, the 5, the 10, the 15, the sodium iodide was the limiting. At the higher ones, what was the limiting? The lead nitrate. The lead nitrate. Okay? So here you're going to tell me how many moles of each reactant you used in each trial. Okay? And all you need to do, I should have made a table like this for you, ladies and gentlemen. I'm sorry I did not. Is tell me how many you used for the lead nitrate. Everyone will be the same there. And then you will tell me how many you used for the sodium iodide, for 5 milliliters, for 10, for 15, for 20. You do not have to show me all those calculations, but you need to do them. Questions? So you are stopping here before the ratio step. I just want to know how many moles of each reactant you used. So take the volume times the molarity. That will give you the moles. Questions? Then here, ladies and gentlemen, you are going to calculate how many moles of sodium iodide should have been created for each trial. All you need to do, because I don't give you a space for you to show me the calculation, you need to just put the numbers in here. How many grams of lead iodide should have precipitated for each trial? That we did yesterday. Okay? That we did yesterday. Right? Okay? So how many grams should have been produced based on the amount of lead iodide? Use your class data for the 6% yields. That's what I was just talking to you about. But again, for this one, the one that is yours, use your number only. Every other one, use the class average. Questions? So this one you need to do 6 times. Okay? 6 times. Okay? Questions? What was the purpose of filtering the solution and rinsing the precipitate? Why were we rinsing it? Why did we then filter it? What ended up in the flask in the bottom that we didn't want? What ended up in the filter paper that we did? Okay? Now, looking at our numbers, which are incredibly high, that tells me we should have done more filters and rinses to get rid of the extra stuff that was in there that we didn't want to be in there. So we should have done more rinsing down of the solution. Because again, when we mix it, everything is in the same container. But I only want the mass of the precipitate. But there's still something else in there. That's what this question is asking. Identify the limiting reagent in each of the 6 trials. Your answer for this should be either lead nitrate or sodium iodide. And by the way, trial 1 through 6, 5, 10, 15, 20, 25, and 30 milliliters. Which was the limiting reactant in each one? Okay? And then in which trial is there no limiting reactant? In one trial, there was none. And actually, I guess a better way of saying it, in one trial, they were both limiting because there's always got to be something that limits it. But in which trial were they both limiting? Compare the number of moles of reactant to the number of moles of product you calculated in calculation 1 and 2 for this. And tell me what you notice about it compared to the balanced equation and what conclusion you can draw. Okay? Now, here's what I will tell you. A lot of these are going to be easier to do after Monday when I am able to give you your table. Okay? When I am able to give you your table. So, the lab is not due until the end of the day on Monday. I will give you class time on Monday to work on this. I don't care if you work as a whole big class together on it. I don't care. But I will give you class time on Monday to do that. So, what we're going to do right now is we're going to take our quiz. And after our quiz, you're going to have time to work on your limiting reactant problems. And please understand that next week on Thursday, you're going to be taking your unit test. Okay? Question. Wonderful. So clear your desks of everything except for your periodic tables and a calculator, ladies and gentlemen, because that's what you're going to need.
To your overall grade. Mr. Brennan, how much are labs worth for our overall grade?
25%.
25%. He's saying 27. No, I need it's a lot of tedious.
Okay. Questions before we get going?
Is limiting reactions on this?
Nope. 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 Getting there. Getting there. Perfect. Sorry. My bad. One problem. That's it, ladies and gentlemen. If you're looking for more, I can give you more, but that's it. One problem. Get it done.